Hello, precalc, and welcome to Chapter 4. This one here is trig and functions, so we're working a lot with sine, cosine, tangent all the way through. We'll do a few bearing things at the end to kind of show you how different things work. And let's get going. Make sure you have your Chapter 4 notes out. It should be pink. All right, so first we're going to work on vocabulary so everybody knows what everybody's talking about. We're going to use the degree measure and the radian measure, so make sure you know how to switch between degree and radian mode on your calculator. We're going to convert between the two. We're going to draw angles in standard position. We're going to talk about coterminal, the length of a circular arc, and angular speed. So let's go here. Okay, an angle formed by two rays that have a common endpoint. So this is rays. Should learn that from your geometry course. So this is a ray because you have one point and it goes on forever in a direction. The initial side is the start side of the angle. Terminal side is where the angle ends. Standard position, the initial side is on the positive x-axis with the vertex at the origin. Whoops. There it goes. Oh, that looks terrible. I hope you can read that. Okay. Positive angle just means it goes counterclockwise, so it starts here and goes this direction. Negative angle also starts at the x, but this time it goes in a clockwise motion. All right. Oh, here we go. A quadrant angle just means it lies on the x or y axis. So when you have a quadrant angle, if this is x or y, let's get a different color here. It would go start here on the x-axis like normal, but then it may end up here. So like a 90 is a quadrant angle, a 180 is a quadrant angle, and so is a 270 or a 0 or 360. Right angles always equal 90, acute or less than 90, obtuse or greater than 90. Old words, just making sure we remember. Central angle has its vertex at the origin. Okay, oops, sorry. Angle whose vertex is the center of a circle. This here's a central angle, my fault. Should have also used that in geometry. Radian measure is the arc length of an angle divided by the radius. So it's the arc length of the angle divided by the radius. So like the arc length of the angle is here, then the radius is here. When the arc length and the radius are the same, that is 1 radian. So right here, arc length equals the radius. That is a radian. Radian measure, so they're not all one, correct? So the radian measure of an angle is arc length divided by the radius. So S, which is the arc length, radius, which is here. Okay, now the length of an arc is 15 inches, so that's this part up here. So this is 15 inches. The radius of the circle is 6 inches, so that's this. So I want to know what this is in radians. So you take the 15 divided by the 6, and I have 2.5 radians. Okay, do yours. What's the angle measure of an intercepted arc length of 42 feet on a circle with a radius of 12? So all you had to do is take the 42 divided by the 12, and you should have got, oops, I forgot my angle measurement. So your angle is 3.5 radians. Make sure you measure, because you have to know the difference between, label, the difference between a degree and a radian. Radian measure in a full circle in terms of pi is 2 pi. So when you are on an XY thing and you go all the way around, that's 2 pi, which you already know, because we've done like for circumference, 2 pi r. Remember those things, or pi r squared? Now halfway around then is pi. So half of a circle is pi units. Degree measure of a full circle is 360 degrees. So now when we're converting between the two, we're going to use that ratio. So I know 2 pi is the same as 360. 2 pi is in radians, 360 is degrees. Of course, we can reduce that, and we get pi over 180. So if I'm going from radian to degree, the radian is in the numerator. If I'm going from degree to radian, then the radian is in the denominator, which makes sense if you need to get rid of the pi or not. So I have degrees, which means I need to get rid of degrees to change to radians, so the degrees must go in the denominator, so your degrees cancel, right? Hopefully from science. So 30 goes into 180 6 times, so 30 is the same as pi over 6 radians. This is a unit circle if you have not figured this out. So pi over 3, I want to get rid of pi this time, so I multiply by 108 over pi, so the pi's cancel. 180 divided by 3 is your 60. Okay, they have to tell you, because 2.3, we're assumed as a radian because it's so small, that it doesn't have to be. So if they say it's radians, you go 180 pi, or 180 degrees over pi, you multiply across and divide, and you get 131.8 degrees. Your turn. Pause and do your work. All right, you should have gotten 43, negative 43. You should have multiplied by pi over 180 because you're reducing the degrees. But this time when you did it, nothing reduced. So you just write 43 pi over 180. 2 pi over 3, you would have multiplied by 180 over pi because you want to cancel the pi's out. 3 goes into 180 60 times. So your answer is that is a 120 degree angle. And over here, 1.8 is also radians. So that's 180 over pi. Should have done your multiplication on a calculator, and you would have got 103.1 degrees. Okay, I hope you did a good job. All right. We are starting the unit circle, and the unit circle is something you have to know. And you have to know all the degrees and angles all the way around. So what this does is the beginning of the unit circle. We're going to go around the unit circle right here in terms of degrees. So it goes, okay, if you ignore these guys right here, these are your 45s. So we just are not going to talk about those for a minute. So you go around in increments of 30. So it goes 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. You also have to do that in pi. So if you look at this, we know pi goes all the way across, right? Now, if we look at our 30s, there's 1, 2, 3, 4. Oh, I drew the wrong one there. Come on, go away. There we go. 4, 5, and 6, right? So this is dividing pi into 6 equal sections. So here I have 1 pi over 6. Here I have 2 pi over 6, which reduces to 1/3. Here is 3 pi over 6, which reduces to 1/2. Here is 4 pi over 6, which reduces to 2/3. 5 pi over 6 and 6 pi over 6. See how nothing goes? And then you just continue. So now I have to get to 2 pi, so we have 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. It is simple fraction reduction. Now let's look at the 45s. The 45s are a little different because they work off of 45. So when you look at the 45s, we have a 1, 2, 3, 4 45s in pi, correct? So now we just take pi and divide it by 4. So pi over 4, 2 pi over 4 this time, which again is pi over 2, 3 pi over 4, and then 4 pi over 4. And then we continue on. 5 pi over 4, 6 pi over 4, 7 pi over 4, 2 pi. Or 2 pi, yes. All right, and that's all that is. So degrees goes by 30, and then it goes by 45s, and then it's pi over 6 and pi over 4. You're literally reducing fractions. Over here, this is a positive angle, by the way. We are going around this direction is what's going on. Here, negative, And it's the same concept, except now you're going backwards. So here we go -30, -60, -90, all the way around in your 30s, and then again in your 45s. And again, now we're counting backwards. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, pi, and continuing around the circle. It's just which direction you're going. You need to memorize those because we're going to learn all those values of sine, cosine, and tangent at those areas. So it helps if you know your pi and your radian measurement. Okay, pause and draw your angles in. Okay, I hope you did a good job. They're just rough sketches, that's all I want. So 160 you should know is between 90 and 180, so roughly in here somewhere, closer to the 180, and make sure you label which direction you went. Okay, 7 pi over 4 we know is 1 pi, or 1/4 pi short of 2 pi, so we go all the way around, almost all the way around. Make sure you're showing which direction you go, and that's 7 pi over 4. Well, my -30 did not stay on. There we go. -30 means you're going 30 degrees backwards. And 3 pi over 2, I think, was a little tricky. 3 pi over 2 is 1.5 pi. Well, 1.5 pi is literally your y-axis. So I hope you did okay on that one. All right, here we go. If not, you should have looked at your circles above and you would have seen it. Okay, coterminal means it has the exact same ending side. So it may have a different degree look, but it ends in the same spot on the circle. So we can add a full circle as many times as we want, or 2 pi as many times as you want. Either way, it's a full circle, just if it's in degrees or radians. So if I have an original angle, 17 pi over 6, and I want to find another angle that's in the same spot, well, I can recognize that this is over 2 pi, because 2 pi is 12 pi over 6, so I'm going to subtract 12 pi, and one angle is 5 pi over 6. I could have also added 2 pi and been at 29 pi over 6. I could subtract 2 pi's, or 2 full circles, and been at negative pi over 6. I could have added 2 full circles. There's many ways to get this. In your homework, they're going to ask for at least one positive and one negative. Sometimes you'll have to subtract more than once or add more than once to get there. Okay, pause and do yours. All right, yours is a degree, so you subtracted 360. So you took the 390 minus 360, and you have a 30-degree angle. Well, if they want a negative angle, I have to do one more. So I'm going to take my 390 and subtract 2 full circles, and I'm going to end up with a negative 330. Okay, then you could have added or subtracted again. So if I would have decided to take 390 and add 360, we could have also done that. There are many, many answers here. These are just a few to help you out, so you can do whatever you want. So what is that? 750 degrees, I think. All right. I hope you did well. Okay, arc length is SR theta. The trick here is that theta must be in radians. Okay, if it is not, it will not work. So if you haven't found the radian mode on your calculator, do so now. You have to change it back and forth through this assignment. Okay, so the arc length of a circle with 6 inches of a radius, that's good because that's what R needs to be. But my central angle is 45 degrees. This is not possible to calculate here. You have to change it to radian. So we use our conversion, our pi over 180, and we reduce this. So 45 goes into 180 4 times. So my radian measure of my angle is pi over 4. Now I can actually do the calculation of my arc length. So I take R times, or your radius times pi over 4, change it to actual inches, is 4.71 inches long, is what we're looking for. So this length right here is 4.71 inches. That can be helpful when you're doing things like on tires and circles and pools or whatever you're trying to calculate. All right, pause and do yours. All right, your first step should have been to convert your degrees into radians, and you should have gotten 2 pi over 3. multiplied by your radius, which was 10. And don't forget to label your answer in inches. All right, let's continue on. Linear speed. So how fast is something traveling? Also very important, especially in gear ratios if you guys are going into engineering. Okay, so we got velocity equals s over t. We have angular speed, or this is actually omega. It's a small omega is how that's pronounced. And this is theta, in case you wanted to know. So if I say theta and omega, this is what we are talking about. Over t, then our velocity is r times omega. So let's do some calculations here. The speed of 45 RPM record. All right, so an old vinyl record. Your parents probably have some in the basement. Okay, so RPMs means revolutions per minute. So it goes around 45 revolutions per minute, which is what we need. I want to know how fast the record is actually traveling on my recorder. So let's look. We have linear speed in inches per minute, because this is what we're talking about, when the needle is 1.5 inches from the center. So this is my radius. I need to know that because it travels at different speeds depending on where it is. So at 1.5 inches out, I want to find omega in radians. So we go 45 revolutions per minute. That's what we were given. This is how fast it's going. It's 2 pi radians per revolution. Well, that's one full circle. That's all we're doing here. So I have one circle in one revolution, which makes sense. Okay, so my revolutions cancel. So now we have 90 pi radians per minute. All right, I'm getting closer, but I still don't know how fast it's traveling. So now I know my omega. So my linear speed now is r times omega. So I take my 1.5, my radius, times the answer we found up here. All right, I'm going to actually type this into the calculator so it makes sense to me because 135 pi inches per minute isn't real helpful. So when we type that in, we get approximately 424 inches per minute for 45. A lot faster than you thought, isn't it? All right, pause and do yours. All right, this one here's a little bit more real world because your wind turbine, if it doesn't travel at a certain amount, doesn't produce the energy you need, correct? At least I hope you know that. So the blade is 10 feet long. Actually quite short. We should have used a real one. Okay, it rotates at 4 revolutions per minute. So I need to find the linear speed in feet per second. So 4 revolutions per minute. So I got 4 revolutions per minute. I know it's 2 pi, or a full circle, which gives me 8 pi for my omega. Now, in order to figure out its velocity, or how fast it's going, I got to take my radius, which was my 10, multiply it by my 8 pi, and I get 80 pi. All right, doesn't mean a whole lot, right? Type it in your calculator. It's going 251 feet per second, and that is what is going to create our energy. Okay, good luck on your homework. Make sure you post questions online, and have a great day.